Good morning. In this session, we are going to see a topic on fluidized bed boilers. In the subject Me8792 Power Plant Engineering, in the Unit 1 Coal-based Thermal Power Plants. Fluidized bed combustion boiler, FFC boiler. It is used to produce a steam from fossil and waste fuels by using technique of FBC. Introduction to FBC. In 1921, the first fluidized bed being used successfully in Germany. FBC has emerged as a feasible alternative and has a significant advantage over conventional firing system, and offers multiple benefits: compact boiler design, fuel flexibility, higher combustion efficiency, and reduced emission of pollutants. The fuel burned in this boiler include coal, washery rejects, rice husks, wood chips, and other agriculture wastes. Fluidization of solid. Sand particle resting on mesh become fluidized when air is blowing through and taken on the appearance and some of the properties of boiling fluid. Granule solid remains in layers when one is supported and poured onto another, but rapid mixing occurs on fluidization. A bed of stationary particles supports objects whatever their density. On fluidization, an object of lower density floats while the higher density sinks. In bed of stationary particle, heat is transferred slowly. There are big difference in temperature. In a fluidized bed, rapid mixing ensures a uniformity of temperature. Characteristics of FBC. It depends largely on particle size and air velocity. Combustion process requires the three states: that time, temperature, and turbulence. Turbulence is promoted by fluidization. In sand particles, in the fluidization state is heated to ignition temperature of coal. The coal will burn rapidly and bed attains a uniform temperature. The FBC takes place at about 840 degrees Celsius to 950 degrees Celsius. Since the temperature is much below the ash fusion temperature, melting of ash and associated problems are avoided. Limestone is used as a particle bed control to sulfur dioxide and nitrogen oxide emissions in combustion chamber. Types of FBC. First one is atmospheric classic FBC system, and second one is atmospheric circulating FBC system, and third is a pressurized FBC system. First one, atmosphere FBC. A coal is crushed in a size of 1 to 10 mm depending on the rank of coal, and the atmospheric air which acts as both fluidized air and combustion air. The velocity of air ranges from 1.2 to 3.7 meter per second. Almost AFBC is boiler used in bed evaporator and for extracting the heat from the bed to maintain a bed temperature. The bed depth is 0.9 meter to 1.5 meter deep. The arrangement of AFBC. It consists of fuel feeding system, air distributor, bed and in-bed heat transfer surface, ash handling system. Fuel feeding system. For fuel feeding system, the absorbance like limestone, usually two methods are followed: underbed pneumatic feed and overbed feeding. What is underbed pneumatic feeding? If the fuel is coal, it is crushed to 1 to 6 mm size and pneumatically supported from the feed hopper to the combustion through a feed pipe passing the distributor. Overbed feeding. A crushed coal is 6 to 10 mm size is conveyed from coal bunker to the spreader by a screw conveyor. The spreader distributes the coal over the surface of the bed uniformly. This type of fuel feeding accepts oversized fuel also and eliminates the timelines when compared to the underbed feeding system. Air distributor. Purpose is to introduce the air through a bed cross section, keeping the solid particle in constant motion. The distributor is constructed from the metal plate having a number of nozzles or nozzle with bubble caps. The distributor plate is protected from high temperature of the furnace by cooled water tubes, static layer of bed material, refractory lining. Bed and in-bed heat transfer surface. The bed can be sand, ash, crushed refractory or limestone with an average size of about 10 mm depending on the bed height. These are two types, shallow bed and deep bed. In-bed heat transfer surface. In FPC, it is necessary to transfer heat between the bed material and immersed surface, which would not be take off tube bundle or a coil. The heat exchanger orientation can be horizontal, vertical or inclined. Ash handling system. First one is in that type. First one is a bottom ash removal. In FBC boiler, the bottom ash constitutes roughly 30 to 40% of total ash, the rest being the fly ash. Ash from the boiler furnace outlets falls into the crusher when larger ash particle is crushed to small size. Fly ash removal. The amount of fly ash to be handled in FBC is relatively very high when compared to the conventional boiler. The type of dust collector are used are cyclone, bag filters, etc. Fly ash carried away by the flue gas is removed in the number of stages. First, convection section from the bottom to air preheater to economizer, and finally a major portion is removed in dust collector. Circulating FBC. Taller boiler structure. Coal is crushed to size of 6 to 12 mm depending on the rank of coal. Combustion efficiency is high as 99.5%. There are no steam generation tubes immersed in the bed. Advantages of overbubbling bed boiler. High combustion efficiency. It gives a lower emission level of NOx and the better limestone utilization. Number of feeding point is less and because the lateral mixing is done by high velocity fluidized air. Pressurized FBC. It is a combined cycle of Rankine and Brayton. The pressurized fluid gas are cleaned off and expected in the turbine. Operating temperature and pressure is 860 degree Celsius to 16 to 18 bar. In addition, the excess of requirement of boiler are met to the need of compressor. Advantages of pressurized FBC. It reduces the emission, improves the combustion and reduces the boiler cycle. Improved cycle efficiency is estimated to 4 to 5% more than the conventional steam plant. Advantage of FBC over conventional boiler. It is a high efficiency, fuel flexibility and pollution control, ability to burn a low grade fuel, and provisions of automatic coal and ash handling system, and no slag in the furnace, no soot blowing. It is a simple in operation and quick startup. Disadvantage is a large amount of power will be required to lift up in silica surface. So the motor of the forced draft fan will be bigger than the other than the conventional system. Thank you.